Product rule and quotient rule. Not always is it feasible or realistic or easy to multiply or FOIL or get everything so that you do not have a product or a quotient. For example, in number 3 right here, we could FOIL this through, but sometimes you can't. So let's look at what happens if we are considering a product or a quotient and we need to take the derivative. So for number 1, we have a product. We have a first term and we have a second term. We have x to the second times e to the x. These are two terms, so this is a product. So if we want to use the product rule, that means that if we have something times something, so we'll say f and g, and we want to take the derivative, that the derivative is f times g prime plus g times f prime. So the way this works is you take the first one, so the derivative f prime of x is the first, so our first term is x squared, times the derivative of our second term. Well, the derivative of e to the x is e to the x. So first times the derivative of the second, plus the second, which in our case is e to the x, times the derivative of the first. Well, the derivative of x squared is 2x. Now we can simplify this a little bit. Notice that each of them have an e to the x. So if I pull out that greatest common factor and move e to the x to the front, then I will be left with x squared plus 2x. Let's try another product rule and then we'll try the quotient rules. So let's go down to number 3. So if we are looking at this as a product rule, we have our first term and we have our second term. So that means that r prime of t, our derivative, is our first term, which is t plus e to the t, times the derivative of our second term. Well, the derivative of our second term means that we take the derivative of 3 minus t squared. The derivative of 3 is 0, and the derivative of minus t squared, bring down your power, so minus 2t, and then 2 minus 1 is 1. So that's the derivative of our second term. Plus, don't forget to finish it. So we had first times the derivative of the second, plus the second term, so 3 minus t to the second, times the derivative of the first term. Well, our first term is t plus e to the t. So the derivative of t is 1, and the derivative of e to the t is e to the t. So it'll look like that. Now, if we give this a quick glance through, I don't see anything that is a common term to pull it out. Yes, we could do our distribution, we could try to combine it, or we can just leave it right there. And either way is acceptable, that is fine. So let's look at our quotient rule. Our quotient rule says that if you have f divided by g, and you want the derivative, it is g times f prime minus f times g prime all over g squared. Now that's a lot to remember. So the way this works is it is the bottom. So if we want the derivative of g of x, it's the bottom, so 2x plus 1, times the derivative of the top, bottom derivative of the top. Well, the derivative of 3x minus 1 is just 3. So bottom times derivative of the top minus the top 3x minus 1 times the derivative of the bottom. The derivative of 2x plus 1 is just 2. All over the denominator squared. So 2x plus 1 quantity squared. This will clean up, so let's clean it up a little bit. So g prime of x, if you do your distribution, we'll get 6x plus 3 minus 2 times 3 is 6x. 2 times our -1 right here gives us -2, but then we have our subtraction. So minus -2, so plus 2. All over 2x plus 1 squared. So that'll give us g prime of x. This 6x and minus 6x will cancel, so we have 5 over 2x plus 1 quantity squared. And that'll be finished right there. Let's try number 4. We have our numerator. We have 5e to the t. And in our denominator, we have 2 plus 3t to the second. So one thing that I like to do when I am looking at a quotient rule is I like to figure out the derivatives before I try to put it into the formula, because then it's just one less thing to figure out later. So that means that if we're trying to figure out the derivative of the numerator, I want to figure out the derivative of 5e to the t. Well, look closely. That's a little mini product rule. You see it? So if we're trying to figure out the derivative of 5e to the t, it will look like our first term, which is 5, times the derivative of the second, the derivative of e to the t is e to the t, plus the second, which would be e to the t, times the derivative of the first, the derivative of 5 is 0. So our derivative right here is just 5e to the t. It didn't change. That's okay. Sometimes it does, sometimes it doesn't. We just have to check and be careful. Our derivative of here, the derivative of 2 is 0. The derivative of 3t to the second, 2 times 3 is 6, and we'll just have t to the first. So now I've got my little derivatives over here. I did not write an equal sign because I am not changing the equation and keeping it equal. I'm finding the derivative, and I'm just making some notes so I can remember it as I work down through. And so the derivative of p. So what does this look like? Well, it looks like the bottom. So 2 plus 3t squared times the derivative of the top. We figured that out. That was 5e to the t. Plus the top times the derivative of the bottom. We figured that out. Oops, sorry, it's minus. Let's fix it. There we go. Top times derivative of the bottom, minus for your product rule.